Okay, time to learn the prediction calculator. This is one of the more useful tools, I think, especially for tasks where you want to create some type of tool for someone to use who's kind of out in the field, like a salesperson or a loan officer or someone who's meeting with a customer, trying to make a good decision on the fly but doesn't have access to the SQL Server or these resources. What we can do is we can do what's called train a model or create a prediction calculator, where someone can simply plug in the values of a particular row, like single, male, 70,000, 0 bachelors, and then have some prediction that says yes or no, they will or won't purchase a bike. And this happens often with pharmaceutical reps or IT software sales. The sales rep is out in the field and they're trying to choose the next company or contact person to meet with, and they want to have the greatest success, right? So they need the ability to say, all right, here are the characteristics of the next person I am interested in meeting with. Plug those in and see if that's a good, likely match for my product, and if not, go to the next one. Plug it in and see if this is the person I should go to next. Similar calculators should be used with loans, although they are often not. We should simply be able to plug in all the characteristics of a potential lendee, and then have it tell us in the end, yes, this person will or won't pay off the loan in the end. So, make sure that you're on the Table Analysis Tools sample worksheet with your cursor somewhere in the table. Click on Prediction Calculator. Now what we want to do is set our target, which of course in this case is purchase bike, to yes. So we want the calculator to help us determine what scores are needed to meet the minimum threshold requirement in order for our prediction to say yes, they will purchase a bike. So our output, well, actually first columns to be used, make sure ID is not checked. Everything else should be okay. Then in our output options, we can make an operational calculator, which is an Excel worksheet. This is probably good for most people because any salesperson will have a laptop with Excel or a tablet at least, so they can use the operational calculator. Or you can have a printer-ready calculator. I'll show you both. Let's hit run. So it's basically doing an analyze key influencers, but it's coming up with the actual scores for each column value pair, rather than simply a bar that tells you the relative impact of each column value pair. So actually three worksheets have been created for this analysis. This first one here says, okay, we have costs of false positives, false negatives, true positives, and true negatives. Sorry, costs and profits. So a false positive cost, this is the effort and time I spent going after someone that I thought was going to purchase my product, but then doesn't. Okay, this is a real cost, and we're going to give some value here. False negative is always 0, because if it's predicted to be negative, meaning we predict they won't purchase a bike, and I don't push this person, or I don't hit this person up for a sale, then the cost is 0. I've spent no effort, no problem. True positive profit means I predicted someone was a yes, and they did. They went through and purchased a bike. This is the profit I make off of them. True negative profit is always going to be a 0 because I predicted that they won't, and they didn't, therefore I made no money. So the actual numbers in these two cells are not as important as the relative difference between the numbers. So whether both are 10 or both are 1 is not a big issue. As long as they're the same number, I'm saying that a false positive cost is the same as a true positive profit. If those aren't, that's where I want to change them. And it really doesn't matter if I put, let's say for example, the cost is only half as much as the profit. Then I would put 5 here. But really, it's not going to make a big difference whether I put 1 here and 2 there, because notice my suggested threshold to maximize profits. It's 463 either way, whether it's a 10 and a 5 or a 2 or a 2 and a 1, it's still 463. So getting the correct numbers here isn't as important as making sure that the relative difference between them is roughly accurate. So what this does is it provides, based on the key influencers report and the beta coefficients that it came up with, gives us some threshold and says, okay, this is a score that each person would need to achieve for us in order to predict that yes, they would buy a bike. And what we have down here are a list of attributes and the score for each attribute. So if they're married, they're not likely to buy a bike. Therefore, the relative impact is 0. Being single is good towards purchasing a bike, but relative to everything else in here in this list, we give it a 45. Okay, females, at least for our types of bikes, are more likely, therefore they get a score of 25. But that's not as big of a factor as being single is. So you get the idea. As you go down here, we've got all of these attribute value pairs and the relative importance and weight that each of them gets. And there's all possible attribute value pairs. Over here, we get the potential profit if we were to use various thresholds. So if we use 195 as our threshold, that means we're going after more and more people because it's easy to meet a threshold of 195. This would be our profit after accounting for both the cost of false positives as well as a profit of true positives. That's eventually going to go up and up as we get closer to this suggested threshold, which is going to be the maximum point in our graph, which is either that point or that point, I can't quite tell. As we move forward and raise the threshold more and more, we're reducing the total number of possible true positive profits we get. We're also reducing false positive costs, but we're reducing more true positive profits, therefore it's going to continually go down, down, down over time. Same thing here, we're showing the same thing but the cost, this classification of cost. So let's leave this. We don't use this report we mainly use just to let us set these false positives and true positives. We go to our prediction calculator. Now we've got, here's our suggested threshold, and this is our calculator for each person. So let's say that someone comes into my store and I start talking to them, not that you would probably do this, but I could say, get to know them, say, okay, you're single, you're female, your income is very high, your children is, we'll put in the middle of the road there, your education's very high, graduate degree, occupation, clerical, cars, 4. So you've got quite a mix here of variables. But your total score is 470, which exceeds the threshold. Therefore, we would predict, yes, this person will buy a bike, therefore we should pursue selling a bike to this person. So here's our individual breakdown again of each of the attribute value pairs. But this is what loan officers should, but often don't use in their jobs. When someone comes in, they should sit there and just plug all the values in into some type of prediction calculator and then say, okay, based on what you've told me, I would approve this loan at this interest rate. However, so many small banks and credit unions simply gather this information and then make a gut feeling decision. They pay no attention at all to any type of prediction calculator. Many of them do as well. Many of them do use a calculator like this, as they should. But this gives you a much more objective way of making a decision. You're less likely to make bad decisions. Lastly, here's our printable calculator. I don't know that this is really that useful. It's just something someone could print out, check off some scores. There are, I'm sure, some contexts where this is useful, and they can total things up and add up a score, but typically I skip this printable calculator when I run the prediction calculator. Anyway, that's all for the prediction calculator for now.